We're continuing with Math 125 gateway questions, this time number 89 out of the pool 81 to 90. The question is h of x equal to sine of square root of 3 minus x divided by tangent of by square root of tangent of 4 minus x. First step, I would like to replace all the square roots by the power that I can replace them with. So that makes it sine of 3 minus x to power 1/2 divided by tangent of 4 minus x to power 1/2. Next thing that I notice is that this is a quotient rule. So let's do the quotient rule. I'm starting with, so derivative with respect to x of h of x is going to be a big quotient line, and derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. Messed it up. Sorry about that. Let's erase this entire thing. How are you doing, Ryan? I had Shefika come over and she did a bunch, and then
I just saw Abba.
Abba just came over and did a bunch. So how was your class today?
It was good.
That was good?
Yeah. I'm starting to get some excuses of I left my homework at home and can I turn it in later? And
Oh, the plan is because Ian is way behind. Ian missed most classes out of all of us.
Oh, yeah.
And so she asked them to turn it in on Monday, so I'm not going to post the solution until Monday.
Okay.
So however you want to handle it.
Yeah. I told them, I think my general rule is if you can get it to me within 30 minutes to an hour after class, then it's not a problem.
Okay.
Just because then I know they don't have enough time to run home, do it, and come back.
Yeah, sure.
So.
Sounds good. Okay. John, I'm ready. Sorry. So now let's do the quotient rule. So derivative with respect to x of h of x is going to be big quotient line with a negative sign in between. Derivative of the numerator times the denominator times minus numerator times the derivative of the denominator over the denominator to power 2. Now, the numerator is going to be sine of 3 minus x to power 1/2. Denominator is tangent of 4 minus x. The entire thing to power 1/2. Again, sine of 3 minus x to power 1/2. Tangent of 4 minus x to power 1/2, and we're taking derivative of that one. Let's find the derivative of the numerator and denominator separately. Here, when I'm looking at this derivative, I see there is the outside function and there is the inside function. Outside function is sine. Inside function is 3 minus x to power 1/2. Derivative of sine is cosine, so I write down cosine, and I put the inside unchanged. Then derivative of inside. Derivative of inside, it's a chain rule on its own. 3 minus x to power 1/2. 1/2 comes down. Inside unchanged, 2 power 1 less. Then derivative of inside, which is 3 minus x. Derivative of 3 minus x is -1. Now, derivative of denominator, the outside function is 1/2. 1/2 comes down. The entire inside to power 1 less times the derivative of inside. Inside is tangent of 4 minus x, which is another chain rule. Derivative of tangent is going to be secant squared. So secant squared 4 minus x, then derivative of 4 minus x, which is inside of the inside. So this is literally unpeeling the onion. Very outside to power 1/2. Inside is tangent. Then inside of the inside is 4 minus x. Here also the same way. Rewriting this entire thing, we end up with cosine of 3 minus x to power 1/2 times 1/2 times 3 minus x to power -1/2 times -1 times tangent of 4 minus x to power 1/2 minus sine of 3 minus x to power 1/2 times 1/2 tangent of 4 minus x to power -1/2. I'm going to continue this one down here. Minus, rewriting what I wrote already. Erasing this part. And then after tangent of 4 minus x to power -1/2, derivative of inside, secant squared 4 minus x times -1. Denominator is for both of them tangent 4 minus x to power 1/2 to power 2. I can put that negative sign between the two fraction lines. This is your final answer. No need to simplify. You can also keep everything in the both numerators above a fraction line and just put in the denominator underneath all of it. The reason I have it into two fractions is because I didn't have enough space on the board. Alternatively, for problem number 89, I like to do I like to rewrite the problem in another way, changing the radicals into power 1/2, also bringing the tangent to the numerator, writing it as tangent 4 minus x to power -1/2. This way I will have a product rule to take care of. The product rule in here, so the derivative with respect to x of h of x is going to be equal to derivative of the first factor times the second factor plus first factor times the derivative of the second factor. To power negative 1/2. Now, replacing each derivative, this derivative becomes, okay, so this is a composition function, so I need to use a chain rule. There is this outside function and there is this inside function. Derivative of outside function, derivative of sine is going to be cosine, and I put in the inside function unchanged. Then derivative of inside function is another chain rule on its own. So derivative of inside function and replacing the derivative of inside function, what we get is 1/2. It's a power rule, 1/2 to power 1 less, times the derivative of very inside, which is derivative of 3 is 0, derivative of negative x is negative 1. So the entire derivative becomes cosine of 3 minus x to power 1/2 times 1/2 times 3 minus x to power negative 1/2 times negative 1. Now let's try to compute the derivative of the second factor. Second factor is tangent of 4 minus x, the entire thing to power negative 1/2. So the outside function is to power negative 1/2 times tangent of 4 minus x to power 1 less, subtracting negative 1/2 minus 1 gives me negative 3/2. So this is the derivative of the outside function, negative 1/2 to power negative 3/2, and inside unchanged. Now I'm trying to take the derivative of inside, so multiply by derivative of tangent of 4 minus x prime. The entire thing becomes, this entire thing becomes negative 1/2, inside unchanged, to power 1 less, times derivative of inside, which is derivative of the derivative of tangent of 4 minus x is another chain rule on its own. Tangent of derivative of outside is the outside function being tangent. Derivative of outside is secant squared. So I replace secant squared, inside unchanged. Now I have to take the derivative of inside, derivative of 4, 0, minus 1. Let's rewrite this entire thing. So what is going to happen is that I'm replacing this derivative by what I computed, and that derivative by what I computed over here. So this entire thing is going to be equal to this part, which is derivative of the first factor, times the second factor plus first factor unchanged times the derivative of the second factor, which is given right here. The final answer is this one. No need to simplify.